Okay, I'm Duncan and I want to talk to you tonight a little bit about cloud. What I'm hoping to do really is leave you in a place where you all have a good feel for what it's about. In a slight change to the kind of advertised title, we're probably just going to do that tonight because we couldn't fit it all in, to be honest. So we've shortened it down a little bit. And if I get straight into it, what is cloud computing? I think most people of late will probably have received lots of mails in their inbox titled cloud, using cloud. It's a term that's used all over the place. But in a way, there's a kind of true cloud computing kind of model. And then there's lots of marketeers who are bringing a term they think everyone might want to see into their literature. So I think there's kind of cloud computing and there's arguably a broader set of cloud services out there. I think it's great to start by understanding where the term came from to help explain what it's all about. Now, if we go back to the mid-90s when the internet was kind of being born and it was being kind of represented on network diagrams, such as this one here, the internet was kind of drawn as a cloud. And really, what people were trying to suggest then is we don't really know how it works. We don't know about all the complexities of the internet, but we kind of know that's what it is and we know what goes into it and what comes out of it, if that makes sense. So the internet is really just like a big network. So the cloud symbol kind of represented an abstraction. It was about not knowing what's in there and not caring. It didn't matter, but if I put a server on there with a website on it, everyone can see it. So that's where the cloud term comes from. It's really about abstraction. If you go back now to thinking about servers, most people have at least heard or maybe seen a server. Not uncommon these days for a mid-sized business to have quite a few of these, maybe in a room, lots of air conditioning to keep them cool, that kind of thing. Often people in there fiddling around with it, lots of flashing lights. And obviously these things are power, space and people hungry. They're expensive. There's some research out there that actually shows that a server costs more to run over its lifetime than it costs to buy in the first place. So when you look at, there's a room full there, it's an expensive asset. Really, where we're at with the current incarnation of the cloud is we're going to hide all that behind this layer of abstraction. We don't care anymore about servers, about platforms, about operating systems to some extent. It's all being hidden away behind the cloud. Now, to try and sort of show you that in a different way, this is kind of a technical diagram, but really don't worry about that. Just look at how many shapes are on there. Bottom right here, we have lots of servers. We've kind of got the concept of an office and some other bits going on. If we move that into the cloud, if we change the model there, it looks more like that. And again, if we go back over here, all these things at the bottom there, we need to know where they are. Someone's ordered a server from Dell, they've ordered a spec, it's got this much hard drive space. You need to understand what you need to go and buy it. It arrives in a box, you unpack it, someone sticks it in a rack or plugs it all together and installs software on it. And that's commonplace mostly for businesses and has been for some time. I think what's good to think about is in the top left-hand corner there, we've got a representation of a hosted server. So that's still in the data center up at the top there, but we've actually gone to the data center probably and said, can I have a server to put this website on? And probably asked for a certain specification and, in the data center, someone's actually gone and built that server and made it available. I think it's an important point to note that in cloud computing, that disappears as well. Because what it's all about is not knowing really where this computing power is coming from. We don't need to know anymore. It takes out the complexities, makes it very simple. Oops, oh dear, sorry, I've gone very far forwards there somehow. real good, isn't it? Not quite sure how that happened. Right, so there is a definition there, but I'm not even going to read it out. Basically, in simple terms, cloud computing is like public transport. If you think about everyone's driving around in their own car, and there's lots of spare seats, and you've bought that car, but sometimes it sits on the driveway, not using it. That's kind of what a server's like. Most servers are overspecified. There's loads of unused capacity there. It sits there burning electric half the time, not doing a lot at all. You compare that to a bus. You only pay when you use it. You buy a ticket, you use it for that period of time, and that cloud computing is about a pool of available resource that you can use and turn off and on like you were plugged into the electric socket. So when you don't use it, you don't pay. I guess the issue with using that as an analogy is that's a crappy old bus, and it's probably going to be late because it's British public transport. So maybe the bullet train in Japan is a better idea of it's a bit more efficient. So moving on, just to try and again ground this a little bit further, what's actually behind the cloud? So where that infrastructure has disappeared out of our businesses, where does this compute power come from? Well, basically, what you've got now is a new breed of data center that's specifically designed and built to host cloud-based computing services. This is a real one. It's Microsoft's data center, somewhere in the States, Chicago, I believe. It's at the moment in the hosting providers, I guess you've got one-to-one, you've got Rackspace. There was kind of a bit of a contest going on about who had the most servers at one stage. I think Rackspace were claiming 50,000. I think the analysts thought that 80,000 was about the most servers that any one hosting provider had. This one data center being built by Microsoft has a capacity of 300,000 servers. And Google have got a similar one as well. So this is the kind of scale of thing that's now underpinning the cloud computing providers. Just to give you an idea of scale, football pitch in the corner, 12 times the size of that, huge, great big building. What we can do, we can actually go and have a look inside here. Unbelievably now, because of the capacity, if you imagine trying to build 300,000 servers and stick them all in the racks, it doesn't work like that anymore. You can't have one individual or a team of guys actually manually doing that work. So what happens is people like Microsoft now, they get on the phone to Dell or HP and they're ordering container loads full of servers already built, configured and all plugged in and networked together in a shipping container. So that data center we just saw there, you can see the layout here. All the red is where the containers are actually plugged in, and literally a truck reverses into the data center with a container on the back, and that whole thing is plugged in to the network, a bit like a clip going into a gun. So we can explore further and actually take a look there. So you can see you've got all these containers lined up, and you can see the kind of rubber seal at the back. They're literally reversed in and plugged in onto the network. Each container has 600 or 700 servers in it, and that's a view in through the window there. You can see just about the amount of power and servers that's in that one container. So this is the scale of these things. So some people may be concerned about the reliability of cloud. There's huge, great, thumping, big amounts of servers and power underpinning it all. So what are the main features and benefits? Well, the real drivers are economics, particularly in the current climate. You'd have to buy a server, you'd have to run a server, you'd have to pay for licensing in the same way. A business could save 70% potentially of their IT costs by moving to a cloud computing model. The other major advantage is elasticity. So if you do have a server or you're hosting a website or whatever it is, you've got some ultimate capacity that's set. With cloud computing, there is no capacity cap. The whole thing can stretch and grow on load, basically. So as more transactions are put through it, the whole thing can scale right across that data center potentially. And carbon reduction, likely to be growing legislation and tax benefits around reducing carbon for a business. And again, by losing that server room and all the power and air conditioning that goes with it, the carbon position is going to become much lower. I think it's important to ask the question, is it all hype? Is it another, kind of technology marketing thing that's happening at the moment? 75% of IT managers are currently evaluating cloud computing. So lots of people are out there using this stuff. Not to say it's in production but people are evaluating cloud computing. I think this is probably the most staggering fact, that 20% of businesses will own no IT assets by 2012. That's not a long way off, and it shows how much momentum is gathering around this kind of model. And finally, the market size is predicted to be huge. Again, very soon, 3 years away. If you think about market needs, the IT industry, it's had a difficult couple of years. IT budgets are being slashed, and what are we spending the money on? So we've got all this idle capacity potentially that businesses are spending the reduced budget on, and then we're spending 70% of that budget maintaining this stuff arguably we don't need. And I think that on its own gives us this huge market driver, and certainly what we've seen as a provider of these kind of services is how Microsoft, Google, Amazon over the last year have rapidly accelerated their offerings, so that they've got a cloud service out there, because it's exactly what the market needs right now, to do more with less budget, basically. So I'm going to hand over to John now, who's going to talk through the more technical stuff.
So going back to Duncan's analogy with the bus and the public transport, quick summary of the evolution of IT in the last sort of few years is traditionally we had a server, and that server had a role. It was either a mail server or a print server or a file server. Then recently we've started using virtualization, where you buy a slightly bigger, more powerful server, but actually that runs the 4 virtual servers. You've gone from sort of 4 servers to 1. Well, cloud is sort of the next progression of that. It's basically taking that virtualization technology, but moving it out of your office and actually into the internet. So what we can do there is there's actually cloud services built in. So what you've got is there's 3 different levels. So you've got software as a service. So that is a cloud offering, and we've all been using that for quite some time. Things like Gmail provided by Google, that is software as a service. You've got basically access to your email, and you can do it company-wide or as a personal individual. But you're not worried about storage or where it is or how it's located. You've just got access to email and a calendar, and you can set it up on your BlackBerry or your iPhone. That's now expanding. So you've probably all seen Google Apps being advertised with their word processor, their presentation software, all free. Well, Microsoft has an offering coming out in the next couple of months called Office 365, which is basically the full Microsoft Office suite, but actually all hosted online. So the only way you access it is via a web browser. So you load up Internet Explorer or Chrome, go onto the site and you log in, and there's your word processor, there's your Excel, there's your Outlook, all web-based, and basically it's done on a subscription fee. The next level is platform as a service, and what they're offering here is actually an instance of a server. Similar to if you were to go to a data center and rent a server, you get an operating system, whether it's Windows or Linux, it's a specific server. You've then got infrastructure, and this is the other tier of the cloud. It's actual sort of the core underpinnings of it. So whether it's network connectivity or just storage, you can actually just purchase those sort of services. So rather than maybe expanding your current servers, you can actually just purchase storage on the cloud and actually bring that into your network in that respect. So what I'm going to show you today is, obviously I'm not going to bother with software as a service because most of us have used Gmail or an equivalent, so we're used to the sort of applications available on the internet. So what I'm going to show you is platform as a service. So if I just escape this here, and what we're going to demonstrate is Amazon's offering. So Amazon has their cloud offering called Amazon Web Services, and they offer both the core services such as storage and platforms. So what we're going to quickly do is we're actually going to build a server just as we would in a normal office. So traditionally we spec up a server, we work out what it's going to be doing. So for argument's sakes, it's going to be an application server. So we're going to want IS and SQL, and we're going to host some sort of web app, whether it's an e-commerce site or whatever. So come up with a spec. We then sort of add a bit to make sure it's going to last us the 3 years that we've bought it for. And then we order it, and it's about 3 to 4 days for Dell to deliver it. Then you've sort of got half a day to put the operating system on once you've unboxed it. Then there's Windows updates. Then there's installing SQL and getting it all configured. So you're actually talking about a week roughly. Obviously, you'll be doing other stuff at the same time, but a week to actually get that server up and running. What we can actually do really quickly is in about 10 clicks, we can build a server and actually have it accessible on the internet. So what Amazon have is predefined images. So you can actually specify what you want on the server. So we're going to have a Microsoft SQL server, so Windows Server 2008 running SQL. So we'll select that. We then can specify actually what spec do we want. So here's your spec drop-down list. So how many processing cores do you want? How much memory? And you can literally go all the way up to saying silly like 68.4 gigabytes of RAM, ridiculously large machines. But we're just going to pick, I know, let's pick a large one there, 7.5 gigs of RAM. So I'll just wait for this. There we go. Next again. We'll give it a name, so we'll Acme 2. Next there. Next there. Here's your firewall, just like you would normally. So you can specify, so what we're going to do is we'll just make this all available to the internet and select that. So this is a firewall. So each server instance can have its own firewall. Click Next. And there's basically the summary. If we click Launch and close that, what we'll see here is there's a server. It's pending at the moment. So Amazon have got the request. They're going to build that server for us. And in any second, we should see that being running. He says. There we go. So that's now actually running, and what we can actually do is that. That's the right one. And there we are. We've got our server, and there's Microsoft SQL, there's IS. That's now ready for us to deploy our application, and that's accessible to the internet. So within, I don't know, 15, 20 seconds, we've actually taken what's normally sort of a 5-day task perhaps and built it straight away. Now, that's nothing too exciting in its own right, but where it becomes more useful is if we go back to here. So that is running. So Amazon charge so many cents per hour for your server to be running. If we were actually to switch that off, so there's a couple down there that are stopped at the moment, you then don't pay for those because they're not running. You only pay for what you're using. And how that's derived is basically on how much storage you want, how much computing power you've got. Now, a lot of us have servers, or our customers have servers, and potentially they have maybe an e-commerce site on, for example, that they're using. Normally, we have 2 servers, don't we? We end up buying 2 servers. You've got your live server and you have a test server, because if you're going to make any changes to your customer's application or your application, you don't want to do it to their live server. So you have a test server. Well, this is where Duncan's 85% comes from for actually not using it. A test server, most of the time, isn't actually being used, because unless you've you've done a new release of their website or e-commerce site and you've uploaded it for them to test before it goes live, it's not doing anything, it's just sat there whirring away. So you need a test server. And again, it's that whole principle. You build a server, you install it, you then copy across the application. It's a lengthy process. What we can do here, and this is the true power of it, is we select the server, we can then go instant actions, and we can go create image. That will sit there and create an image. We can then click on launch instance, and you then have your own images. You select that image, and then instantly, with the same amount of time it took to build that first server I showed you, we've made an exact duplicate of the live server. We can then do our changes to it, get the customer to log in, test it, make sure they're happy with it. If they are, we can then make the changes to live, and then all we do is we go in here, cancel that, and we terminate that server. So potentially, if your test period is a week for the customer, you're only going to get charged for this server for 1 week. And in Amazon's pricing, that works out probably about $60. So instead of that £4,000 or £5,000 server you've had sat there, which you use sort of once a week every quarter or something like that, you've got, you know, what, £40, £45 worth, and that's actually up and running. You then go down to sort of a more granular level of, well, how does it dynamically work? How does the cloud dynamically expand? Because obviously I've gone in there and I've spec'd a server. It literally is as easy as a couple of clicks. So volumes, in this case, this is storage. This is one of their core underlying services. And all we can do here is we go create volume. We can say in either gigabyte or terabyte, however big we want it. So we have 10 gig, go create, and that will create us a 10 gig storage capacity. If we want, we can go in and edit that and change that to 20 gig. And again, what we can do here is we can literally just, there's one that's available while that's building. We can go attach volume, attach it to our server that we've just built. I'll give it a drive letter. And then what we should see here, if I quickly open my computer, is any second, an additional hard disk is going to appear. And there's our additional storage. Well, what if that needs to grow? What if we easily use up those 10 gig? Similar to how you do the server, you create a new disk, you give that perhaps, say, 50 gigs, and then what you do is when you create that, you can base that on a previous disk. So what it does is it takes an image of all the data that was on that disk and copies it onto a new disk, and then on the fly, you can swap those disks. So you don't have any downtime for your customers. There's no sort of disruption, which also means you guys don't have to work late at night sort of waiting for everybody to go home before you can make the changes. You can actually do that on the fly. And perhaps I didn't attach it to the right server. Possibly be. What was that? I think I've attached that to the wrong server. Yeah, I've attached it to the wrong one. It's these things there. But basically what you would see is you would see a D drive appear and you'd have your additional disk space there. Now, on a grander scale, let's say you've got an e-commerce site and what you need to do there is ensure it's always available. So we recently had a customer that had moved to the States, and their case point was they actually managed to get some national TV coverage over there, and instantly everybody went to look at their website to see what they were about, and the thing fell over, basically because it was a bog standard server in a data center and just couldn't cope with the amount of traffic. Amazon has what they call elastic compute, and what that does is how we took an image of the server, it takes an image of your core server and waits and sees how hard your current server is running. And once it gets to say 70%, it then creates another virtual server for you and load balances them, and then it creates another one. So your server never fails over. You're literally just constantly expanding it in that respect. If the peak suddenly drops, the Christmas sales are over, nobody's hitting your e-commerce site, Amazon automatically removes those additional machines. So you instantly got the ability to sort of take 500 times the amount of transactions you normally were. Yes, your Amazon bill goes up, but as soon as your sales start reducing, Amazon removes those servers automatically, so your bill then reduces accordingly. So it allows you to basically dynamically have the data on the fly. So there we go. I think let's hand it back over to Duncan now.
There you go, so right, isn't it? So, I mean, in summary, our view, and we've made money out of doing this stuff for years, really, is we can't do this anymore because, this is a paradigm shift, really, in the way that IT's bought, probably, over the next, and it's going to happen, this year is the year when all the services are there and, people are going to start making the shift. I guess that's it. Sorry, sort of quick whistle stop through, bit of technical content which might not have agreed with everyone, but
great. Let's give them a round of applause. Thanks, guys.
Thanks.